Okay, this 12.1 is to solve the first 4 problems on your test. And you've seen this on the quiz. The instructions are given that x varies inversely with y, y varies inversely with x. Use the specified values for x and y to write an equation which relates x and y. Remember, there's a second question. Then find y if x equals, here in this case 5, we could say 3 or 2 or 1, it doesn't matter. Okay, so I'm doing evens, right? So let's look at number 4. X equals 9, y equals 2. Well, we're told y varies inversely with x. So the governing relationship is y equals 1 over x. Sorry, a over x. And I'm told that y is 2, so I can put 2 in the place of x, and x is 9, so I put x in the place of 9 in the place of x. And when I solve, I find a equals 18. So I can answer the first half of this. I can answer y equals 18 over x. But I'm also told find y if x equals 5. Well, that's easy. If I put in 5 for x, I get y equals 18/5, which if I simplify as a decimal, I could leave this way, or I could, as a decimal, write as 3.6. There's, right, both correct. All right, that was number 4. I'd like you to do number 6 on your own. Pause the video, and I'll do it when you come back. All right, let's do 6. X equals -6, and y equals 6. Again, given that y varies inversely with x, so that means our governing equation is y equals a over x. I'm going to substitute my y and x values in, so I get 6 equals a over -6. When I solve for a, I get a equals -36. So my equation is -36 over x, which is again the first half. The second half, again, I'm supposed to put what is y if x equals 5. Well, if x equals 5, then y equals -36 over 5, which again you could leave as is or solve as a decimal as equal to -7.2. Both are correct. Okay, now this is not in the book, but I am going to take you through something which you're going to want to know, because if I don't, you'll struggle with it on the test. There is a problem on the test which is not in the review, and I want to make sure I do it with you. So I'm going to go back to chapter 12, to example 5, and do that again with you because you're going to need to know this for the test. So this is 12.1, example 5, and this relates to number 4 on the test. So here's a table that you're given. With x and y values. And x is -5, -4, -3, positive 4, 8 and 24. And the corresponding y values are 2.4, 4, negative 3, negative 1.5, and negative 0.5. And you're asked, tell whether the table represents inverse variation. So that is your first goal. Does this represent inverse variation? Now again, you go to your equation. Inverse variation equation says y equals a divided by x, which means that if I multiply both sides by x, a, whatever this is, must equal x times y. And a table is just a bunch of xy pairs. So if I multiply all these xy pairs together and they all have the same value, then I can say yes, it must be an inverse variation equation. So let me just try a few. Negative 5 times negative 2.4 is going to give me negative 12. Oh, positive 2.4, pardon. And negative 3 times positive 4, obviously negative 12. And positive 3 and positive 4 and negative 3, also negative 12. And 8 and negative 1.5, also negative 12. And finally, 24 and negative 0.5 is going to give me negative 12. So all of these are going to give me the same value, which must be, therefore, this is the value a. And so my equation is y equals negative 12 over x. Okay? And so that's how you find an equation if there's an inverse relationship in a table. Okay, I'm going to stop there, and we've covered all the way through evens, which at number 6, we're going to do the others a little faster, but I wanted to make sure we went right back to the basics before we move on.